at the corrosion as a mechanism, there are 4 components or essential parts of any corrosion cell. So, there anode, you should have an anode, you have to have a cathode, and you have to have a ionic conductor and an electronic conductor. So, here you can see here the region which is corroding from the metal surface, this was the original metal surface. So, this much metal has been lost. So, this region is what is getting corroded, and that we call anode, and the other the remaining region on the steel. So, here it is the metal, the grey part is the metal, the remaining region helps this anode to corrode, and the electronic charge actually get passed from the cathode to the anode right through the metal itself. And if you are talking about an electrolyte like a water or even concrete if you want to say, but water is also electrolyte. So, if you have it, then there is a ionic conduction happening through the water or through the interface between the steel, the metal and the electrolyte. So, you have this exchange happening here. So, that is ionic conductor. So, you have to have these 4 components. If I can get rid of one of this, I can stop corrosion, but that is not what that does not happen. So, what happens in the when you talk about steel in concrete, again similar thing, like you have on the anodic side you have iron which get this into Fe2 plus and 2 electrons. So, you can here you have this release of Fe2 plus into the solution, and provided you have enough moisture and oxygen in that environment, what will happen is these 2 electrons which are coming from anode to cathode, and they will combine at the cathodic site. So, they will combine here, and then you will have 2 hydroxide ions formed. Now, why I put this picture here is, here you can see that this concrete pier is coming out of the water body, and here you can see a lot of corrosion or damage, whereas here there is no damage, and here if you go deeper into this pile, there also you will not see any damage, but here you will see lot of damage, or you are seeing lot of damage. This is mainly because when you go here you do not have enough oxygen, when you go above the water body you do not have enough moisture, but here you have both oxygen and moisture available in sufficient quantity, and also this wetting and drying accelerate the movement of chloride towards to inside the concrete pier. So, in combination we have more corrosion at the place where it comes out of the concrete.